Okay, guys. Lesson 7 is integration by substitution. Okay. Similar to integration we've already been doing. Kind of the next step up, I guess. Some of what we've already been doing where we had to figure out, okay, what are we going to use to compensate for the fact that, oh, there's a 2 here, we don't need this 2 here, you know. Those pieces can be used, or can be dealt with through use substitution. So we're going to be dealing with probably the fancier versions of those, where it's how do we deal with that, okay? So the key to use substitution is finding a piece of the function whose derivative is also in the function. And I kind of talked about that. We haven't officially used use substitution, but I kind of talked about that when we were kind of guessing and checking on that one page, didn't I? The page that didn't really go with the notes, that was that last page of homework that was difficult. That's the idea, okay? The derivative is allowed to be off by a coefficient, but otherwise must appear in the function itself. The role of substitution in integration is comparable to the role of chain rule in differentiation. Okay? Procedure for using use substitution. Look for a piece of the function whose derivative is also in the function. If you're not sure what to use, try the denominator or something being raised to a power in that function. Okay, those are the hints they'll give you. We usually call it use substitution because you will set u equal to that piece of the function, and then we're going to take the derivative of that with respect to the variable. And then we'll have u, and we'll have what the derivative is, so we'll have du. And we're going to use those to replace the integral to make sure basically that everything is covered. Okay? And then the new integral is something that is easier to solve, is the idea there. Okay? Really, we just need to get to examples for it all to make sense. But substitution, it's a way to undo the chain rule. This is when you're given a function within a function, and again, the derivative is there. That's your chain rule. Okay? I don't know. I think I'm going to jump to, and here again, the integral of f of g of x times g prime of x becomes capital F of g of x. Okay, so again, that chain rule just drops out. But let's see. This goes back to the idea that the power rule. How do we integrate with a power? We add 1 to the power, right? So it becomes n plus 1. We divide by that new power. So n plus 1 on the denominator. And then, of course, we'll have these, I think, are these all indefinite integrals? I don't know. A lot of them are indefinite integrals, so we need to remember to put on the plus c's today. Okay? So the idea here is equivalently, if you do use substitution, it's u to the n plus 1 over n plus 1. And again, you're just integrating that piece. You don't have the fancy looking g of x. Okay? Let's try examples. Okay? I mean, these pages have good information on them, but
Makes no sense.
exactly. We need to just do some problems. Okay. Now, as we do use substitution, I'm not going to usually argue with you if you say, oh, I could have done that without using use substitution. Because I agree, as we become more skilled in integrating, there are times where we might use substitution today that later on you'll be like, I don't need use substitution for that. And it's all as you get more practice and you get a better feel for it. Okay, so if you had any of these, you're like, that was too easy. We didn't need to use substitution. Just deal with it, okay? Okay, the fact that you think you can do it without use substitution, you're starting to see how it works. Okay, so if you go back to the previous page, it gave you suggestions of what to look for to use for u. It said you want to use something where you see the derivative is also within the integral. It suggested denominators. It suggested insides of powers. Those are all options. So with this in mind, thoughts on what we want to use as u? So x squared plus 1 because, what do we see there? The derivative of the x squared plus 1 is 2x, or it is the inside of a power. Now, here's the deal. while we can, to an extent, just say, oh, well, this is something raised to the second. My answer is this raised to the third. There's other little details here that we have to watch out for. And that's why we're using U substitution. So we're going to say U is x squared plus 1. So just because I was moving closer to the door, were they extra loud today?
No, they're extra loud.
I think maybe it's because I was standing just this much closer.
No, I could hear them from over here. They were just loud.
Okay. Now,
And there's more.
once you have picked your U substitution, your next step is to take the derivative. Now, we're going to use differentials to do that. The derivative of U is just 1, but then we're going to say du. The derivative of x squared plus 1 is 2x dx. We're not integrating right now. We're taking the derivative. That's the thing. You've got integrate and derivative all in the same problem here. Okay. Now, if this is working out, we can see pieces matching up. So right here, what do you see? U is x squared plus 1. Do we see that here? X squared plus 1, that's going to be U, right? So when I rewrite this integral here in a moment, we're going to have U, but it's going to be U raised to the second.
Where did the dx come from?
U
Plus
squared.
1.
This dx?
Yeah.
Okay, this would be the same place. It's you're taking the derivative with respect to what?
X.
X.
But why
Okay.
do you have to do, I thought the derivative of 2x was just 2.
No, but it's
No, derivative is a derivative of x squared plus 1. Okay, we're not doing, okay, this is not a chain rule here. This is the idea, okay, so another way to have said this. When we take the derivative of u, kind of like when we would, if this had been y, we could say y prime, or we could say dy dx. So we could have thought of this as the derivative being du dx is equal to 2x. Does that make more sense if I do it that way?
Same thing.
That's the same thing, because then this is du divided by dx. How do you get the dx over here?
Multiply.
You multiply both sides by dx. So then there's my du equals 2x dx. Okay? The deal here is we need the variables separated here. I need my u's to be separated from my x's. So general rule of thumb is you go ahead and separate as you go. So just like when we did differentials, I don't know, sometime first semester. Anytime when you're taking the derivative of u's, we tag on du's. When we take the derivative of x terms, we tag on dx. Okay? Does that help a little bit? Okay. Now, what else do we have left to look for? Do we have a 2x dx?
Yes.
Yes, and that's going to be replaced with
Du.
du. Here's the question. If we've done this correctly, everything is covered. Is everything taken care of?
Yep.
Yeah. And so at this point, we are ready to integrate. So I'm going to rewrite this in terms of u. So x squared plus 1 to the second becomes
U squared.
u to the second. 2x dx
X squared.
is du. All we're integrating is the integral of u squared.
2u. No. Oh wait, no, we're integrating.
1/3
1/3
u.
Okay. The integral of u to the second, you add 1 to the power and divide by the new power. So u cubed over 3, or 1/3 u cubed.
U. No.
And we tag on at the end,
Oh, plus c.
Let's see.
plus c. Now, this is not our answer though, because our original problem was not given in terms of u. Our original problem was given in terms of
X.
x. So we need to go back to x, which all that is that's a simple substitution or simple replacement. What do we know about u?
X squared plus
It's x squared plus 1. So you're just going to take what you had here, which is 1/3 u cubed, and instead it's going to be 1/3 times what u? X squared plus 1 cubed
Plus C.
plus c.
My brain went automatically did like derivative instead of integration.
I know. And I didn't say anything because I'm like, well, I know I had a look on my face. But I'm just waiting for others to fix your mistake. Okay. Now, I think that's one you guys can see, can't you? Okay, that one is one that's fairly easy to see. We expected it to be something to the third. But this just proves that that 2x is legitimate. Okay? And if you wanted to now, you could take the derivative of this and work back, right?
The 1/3 cancels.
3 times a third, it cancels. X squared plus 1, subtract 1 from the power, and it's 2 times the derivative of x squared plus 1, which is 2x. Okay? Okay, I'm going to try another one unless someone stops me. And half the battle here is what do we want to substitute in, right? Okay. Integral of 4 cosine 4x dx. If you do 4 cosine, it has to be 4 cosine 4x, and that's the whole thing.
I'd just say we do 4x.
Okay.
But
So
you got
yeah.
4, which is the derivative of 4x.
look for that inside, okay? When you have a trig function here in that situation, think about the inside. And again, this is the part that takes practice right now. You'll start seeing it eventually. Okay, if u is 4x, that's my, and it, you know what? If this doesn't work out at all, then you go back to the drawing board and you start over and you try something else.
Why shouldn't it be just cosine?
Because that's the whole problem.
That's
Well-
not the whole problem. It's 4 times cosine 4x.
But the 4 is just a constant. And here's what I'm going to say. If I put a cosine x over a cosine of something over here, then I'm going to have to take the derivative of cosine, which is sine of some sort, negative sign. There's no negative sign in here. So that right there, because this is only cosine, I can't use it over here because there'd have to be a sine also, which would basically be part of chain rule. And we don't have that. So, okay. And wait and see how this works out, okay? I promise it works out. If u is 4x, okay, derivative,
du equals 4dx. You have 4dx.
derivative of u, du, derivative of 4x is 4 dx. Okay? So now, check your pieces. U is 4x, so what's that mean? We're going to be doing u, and that's going to be cosine of u, yes? And then du is 4 dx. Do I have that?
Yes.
4 dx. That's going to be du. And then the cosine is just like last time. It was a raised to the second power. The cosine is just part of the function. Okay? So, let's rewrite this. This is the integral of what? 4 dx is part of du, so cosine
Of u du.
I'll be honest, this is one that I wouldn't use substitution for in my calc career. Okay. So, okay, what's the integral of cosine?
Negative. No, it's a sine.
I'm going with sine, yes?
I changed it.
And here's my brain checking. I tell you what I'm doing. I say, okay, what's the derivative of sine? It's cosine. Okay. I got the right plus or minus sign. And what do I do to finish this off?
Let's see.
Okay. And yes, don't forget the plus c. Replace u. So u goes back in as 4x. Okay? I don't think Kylie's okay with it, but
I usually lay my bed a little bit and
I know, it's like I can't function today.
I can't help with that.
I just like I just don't understand.
okay, C.
Thank you. That was so funny.
What'd you say, Hannah? Okay, so if we look at the inside of the radical, which is going to be the inside of a power, right? And as I start looking, I think I see the derivative of 4x squared plus 1, don't I? So u is 4x squared plus 1. Then du is 8x dx. Okay. Look and see how this is going to sub back in. 4x squared plus 1 is going to be u. 8x dx is going to be du. What do we have on the u? Yeah, officially we are integrating the square root of u. And then du, everything else is covered, yes? However, you're probably not thinking of it as a square root, are you?
You do the 1/2.
Okay, at least I hope you're not.
2/3.
Well, if you were thinking about it just as a square root, you were probably stuck in saying, I don't know how to integrate a square root, right? Okay, so integral of u to the 1/2 du.
So 2/3 u to 3/2.
Add 1 to the power. 3/2. Divide by 3/2.
Times 2.
But I don't think you yet see me write that because dividing by 3/2 is multiplying by 2/3. And then?
Plus.
And then? Plug your x value back in. 2/3 4x squared plus 1 to the 3/2 plus c. And I feel like 3/2 they usually leave it as a 3/2.
This makes so much better sense than what the front page is saying.
As I said, we just need to get to it. Quit wasting my time and get to it. Okay. Are you thinking ahead of me?
No.
Thinking ahead of your peers?
I am. I'm not.
U. U is x squared plus 2.
Could you be x squared plus 2?
Maybe.
What if it's x and you guys are all
The
wrong?
derivative of x squared is 2x.
So it's slightly off, but here's the deal. The derivative of x squared, I agree, is 2x, but 2 is a constant. We can make that work.
Yeah.
Okay, we can compensate for an extra constant. An extra variable, we've got a problem. An extra constant, we're going to compensate. So let's go with it, okay? So, in other words, I'm saying, yes, this is right. Well, this is more where you see u substitution as a necessary. Okay, so derivative of u equals, okay, and this is where we start checking. Does everything match up? So we have x squared plus 2 here.
I have a question. What's the
Which-
2 before the x?
We're getting there.
What?
This 2 right here is a derivative of x squared. We're getting to how to match it up here in a moment.
Oh, okay. I'm sorry. Like everybody, like they all said it and agreed, and I don't understand why.
Wait, why there's a 2x here?
Yeah.
Well,
What's the derivative of x squared?
Oh, is that what we're doing?
Yeah. What did you think we were doing? I'm really concerned on what you thought we were doing. You're just taking the derivative there.
Oh.
We still have like 3 more hours of school too.
Okay.
We all have to
Are
get
you
it
okay,
together.
Sophie?
Yeah, I
Seriously?
got it.
Okay. Okay. I'm like, we took the derivative. And you're still like,
let's see what she
Okay, I got it.
I told Natalie I'd go to weights
I'm
after
gonna
school.
disintegrate.
Oh my gosh.
My Natalie? Okay, I guess that she's never hasn't told me what she's doing. So
Oh.
you don't have to. She has a game tonight, so she doesn't have to go. Because isn't it arm night?
Yeah, that's probably why she's going.
And that's
She's
exactly.
Like,
So she's like, if it was like that, I would
it's
be
like, I'm
going.
gonna go get the 25s. I was like, I'm gonna stay here with my 15s.
Okay. Back on topic, sorry.
Sorry, I got distracted.
Now, so we see x squared plus 2, so we see u cubed. Now, what's supposed to happen is x dx is supposed to match. However, it's close, but not quite. So, what can I do to this to make it x dx? What can I do with the 2? It's 2 times x. So let's divide the 2 over. And so essentially if we divide the 2, I don't normally write that division step, but du over 2, which I tend to write as 1/2 du, although you'll see calc teachers leave it as du over 2, equals to x dx. Now, does it match? Now we have an x dx. So here's the trick. X dx is going to be replaced with 1/2 du. Instead of just replacing it with a du, we're going to replace it with 1/2 du. Okay? So, let's do the setup. Okay, x squared plus 2 to the third is rewritten as u to the third. X dx, I'm going to replace with 1/2 du. Now, you could, if you want to, say times 1/2 du. Or what is more typical that you'll see?
du 1/2 alpha.
1/2 du. Did I just put the same pieces in?
Yes.
I just put the same pieces in, yes? I'm not changing. The pieces are all there. Does everything match up? X dx was right here. I replaced it with 1/2 du. And the other part was u cubed. Everything is covered. Are you sure?
Yes.
Okay.
I think. It'll be better once we keep going.
Okay.
I'm gonna hit you in the head. So
Now, recommendation. The 1/2 out front, carry it down. It's a constant, which is why I placed it outside the integration sign. Does it have to go out front of the integration sign? No, we could go in there. It doesn't matter. Okay, integral of u cubed.
U to the 4th over 4. Yes.
1/4 times u.
Plus C.
Plus c. Okay. Clean it up and put x back in. Can we do that all at the same time, I think?
Yep.
All we're cleaning up is 1/2 times the 4th.
Wait.
1/2 times the 4th is 1/8. U to the 4th,
X squared plus 2 to the 4th plus C. Yes.
Oh my gosh, I did that myself.
and as I said, the more we get into this is why U substitution has a need. We have a need for U substitution. It's these fancier ones, okay? It all works out in the end. You just have to get it there.
To the 6th. I really want to do this next one. Do I put it in the fraction?
Can we not do it? No, we're doing it. Okay.
How are we gonna learn?
I'll look at the end.
Okay. That's only a problem on the test. Okay. Thoughts on U?
4x squared plus 3.
4x squared plus 3. It's in parentheses, and it's in a denominator, yes? Okay. So U is 4x squared plus 3. Then du is
4x. 8x.
Jesus Christ. I have 8x.
now. What I will say,
Sure you do.
what I will say is, as these mistakes are made, you know, we know how to do derivatives. We've known how to do those for, at least half of the first semester. We now are throwing in integration, which is going the opposite direction. Beware, you will get confused. You will go the wrong way at times. It stinks, but it's the truth.
As you saw in the first one.
Exactly. It's already been done. Okay, now, let's see what matches up and what I need to do. I mean, in all honesty, you can kind of already see.
You match.
Is the 8 going to match?
Oh, no.
That 8's not going to match, is it? So what am I going to rewrite this as? 1/8 du equals x dx. Okay, so 4x squared plus 3 is going to be u. That power of 6 is good, right? That's just a power. So we're going to have that u to the 6th. X dx matches up with 1/8 du. Does that take care of everything?
Yeah.
Okay. Let's go. So, the integral of, 4x squared plus 3 to the 6th. How are you rewriting this?
U to the 6th. Du.
1 over u to the 6th?
Not how I was going to do it, but I'll do it. Okay, 1 over u to the 6th.
U to the negative 6.
Can we?
Okay. Hold on. Let me do it this term. U to the 6th. Are we good with u to the 6th in the denominator there?
Yeah.
Okay, so that takes care of the denominator. X dx. X dx gets replaced with
Du.
1/8 du. Now, the du
Puts out that.
we can put there, or you can put the du over u to the 6th. You'll see that.
That's what I do.
That's fine. And then out front is where I can put my 1/8. The way I did it,
Putting the du.
it's 1 over u to the 6th. Now, Hannah said she wrote it as du over u to the 6th. That's fine. You'll see that too. They're both good. That's one of those things. There's so many different ways you can write it. Okay, now, what I started to do, but no one was picking up on it first, so I didn't. What are we going to do to integrate this? This is what?
U to the negative 6.
So now I'm going to say 1/8 integral of u to the negative 6th du. I was trying to go ahead and do that. You guys weren't picking up on it, so I just kept moving. Okay, I'm going to keep my 1/8 out front. I'll let you guys look up when you're ready.
Negative 1/5.
1/5, isn't it
Yep.
1/7?
Yep, it's negative 1. Because you add 1 to the power.
What's negative 6 plus 1?
Oh yeah. Shoot.
Or it's a negative number and we just don't know how to add to negative numbers.
Or that.
I don't know that necessarily has anything to do with derivative. It might, but well, I already started writing this, so is that how I wrote it in my answer key though? Nope. That's what I thought.
Oh my gosh, I did that myself.
I got 1, negative 1 over 40 times the quadrant 4x squared plus 3 to the 5th plus
To the negative 5th.
no, to the 5th. So take the denominator.
Put it in the denominator.
It depends if you put it in the denominator or not. Officially, we should. We shouldn't leave negative exponents. In calculus, sometimes it goes. It flies. It's fine. So, okay. I didn't talk that whole piece out loud. I added 1 to negative 6 and got negative 5. I divided by negative 5, which is the negative 1/5. I cleaned that up. Negative 1/40. Plugged in my u value back. 4x squared plus 3 to the negative 5th. I had already started writing that out when I realized, oh, it was a negative exponent. I should have put it on the bottom. So I rewrote it a second time. 40 was on the bottom. 4x squared plus 3 to the 5th is on the bottom. Yeah. Okay. Let's do it.
7 minus 2x cubed.
It's the inside, right?
Yeah.
You're starting to see that.
Of the inside.
The inside of the inside. Okay. So u is 7 minus 2x cubed. So that means du is
Negative 6.
6x squared.
squared.
Negative 6x squared
Yeah.
dx. If you want to go ahead and glance, are we getting good enough now that we're realizing
That we need a negative.
that negative 6 isn't there, is it?
Yeah, we know
So divide it over.
negative 1/6.
Negative 1/6 du
X squared.
is equal to x squared dx. Okay. We have a u, right? And we have an x squared dx. Are we good? Everything's taken care of, right? Okay. How are you? Well, I'm going to go ahead and write it the way I want to.
Is that u to the 4/3?
Okay. You can write it how you want because you can always wait till the next step. The cube root of something to the 4th. I went ahead and wrote that in the first step as a power because I'm not integrating a root, am I? I'm integrating a power. So negative 1/6 u to the 4/3 du is what I'm integrating. Do you want me to just work this on my own and you guys will look when you're ready?
No. Well, yeah.
Over 7 u to the
Mario,
Sorry.
if I'm working on my own, look when you're ready. That means you're not supposed to say it out loud either. Let others work.
Mario.
Add 1 to your power, divide by your new power.
Oh, that's negative 3/2.
Did I find a mistake here?
I see. I didn't simplify my fraction.
What is 7 times 2?
Which that'd be legit though.
What do you want?
What?
Open-ended, right?
Open-ended, yes. Multiple choice is going to be simplified. So we're talking about the fact that you have to do negative 1/6 times 3/7.
Yeah.
I looked and said, oh, 3 and 6 reduces to be 1/2. So it's really, ends up being 1/2 times 7. And I just left it in the 7/3 power. That's not one you necessarily put back in radical form. Not that you can't, but. So we really only got 1 page of examples done.
What? A productive
But
period.
those last 2, I feel like you guys did more on your own. Okay, tomorrow we will finish notes. I only have 3 pages left. Well, we get to look at some tricks. I mean, we did the basics of use substitution today. Tomorrow we're looking at more of the tricks.
Very odd.